I'm thrilled to be here today to share some exciting features that will supercharge your app's performance. And today I'd like to tell you a story. I'm going to share quite a few stories with you today actually, but not the typical fairy tale, but a story about the web performance and lazy loading. So let's start with the first one. Have you ever heard the story of the tortoise and the hare? Well, if not, then today we are going to reimagine that story in a context of web performance. So let's give it a try. Once upon a time, in a land of front-end development, developers raced to make their apps the fastest. And some of them actually believed that the only way to win the race was to preload everything. Much like the hare, they try to load everything at once, eagerly load every component, image, every bit of JavaScript, dumping the entire buffet onto users' plate before they even pick up the fork. Meanwhile, the REST developers, just like the tortoise, took a little bit different approach, loading only what is necessarily at the right time and avoiding this extra unnecessarily baggage, constantly delivering a smooth user experience. And in the end, just like in a fairy tale, the tortoise, the one who took this slower approach, crosses the finish line first. So today I'm going to show you how sometimes the slowest approach can be actually the fastest way to win the performance race. But before, let me quickly introduce myself. My name is Jarek. I've been working with JavaScript for almost 18 years now, so quite a long time. I'm a lead technical architect. I love sharing my knowledge. Like Chris said, I'm the organizer of Angular Catch-Up podcast and coordinator of Angular Toronto Meetup. I'm also a mentor in Angular Space community. You can find me on Twitter as well as on LinkedIn. Feel free to reach out to me. That's all about me. So today we'll cover 4 core topics that are key to improve our web performance. So we'll start with image optimization. Then we'll talk about how lazy loading routes can dramatically improve the performance. We'll check the defer blocks in action and see why hydration makes server-side render apps efficient and how incremental hydration can take it even further. And of course, we'll put everything to the test with a live demo. So finger crossed. I mean, what could possibly go wrong during the live demo, right? So let's start. And let's start with the definition. I imagine many of you are familiar with it, but for those who aren't, lazy loading is a powerful technique that allows us to delay the initialization of certain part of our application until they are actually needed. So instead of loading everything at once, lazy loading lets us load different parts on demand. And this approach offers several benefits, like it can greatly reduce the bundle size and speed up the initial load time. So to give you some context for this, let's talk about some mentioned techniques, and let's start with lazy loading images. And again, let's start with another story. So let's imagine you are walking into a restaurant, ordering a food, and instead of serving you the dish you requested, the kitchen decides to prepare the entire menu. Every possible dish, every variation, all at once. So you sit there, hungry, waiting and waiting, while the chefs try to cook everything. And that's exactly what happens when an app loads every image upfront, even the ones that user might never see. So browsers got this, I call it a bad habit of eagerly downloading every image the moment the page is loaded, even if they were burned down in some sections that user might never scroll to. So this is inefficient and definitely slow things down. Now, Angular has introduced a great feature for handling and optimizing images, ensuring they load faster without really compromising the quality. And the ngImage optimized directive is in the center of this. Right, let's talk a little about this directive. I know that Son will explore it in details, but let's explore its attributes that help us speed up the initial loading time. So first, for images that aren't immediately visible, lazy loading is the way to go. And by applying ngOptimizedImage, Angular automatically lazy load any images that comes into the viewport, meaning users don't have to wait for off-screen images before interacting with the page. And this small change makes a huge difference, particularly on slower networks where users no longer have to wait for images that they haven't even seen yet. And of course, not all images should be lazy. There's some critical or key images like the hero banner, logo types that should be prioritized and loaded as quickly as possible. And that's where the priority attribute comes in, ensuring that all the key images are loaded eagerly, meaning there is no delay, with the fetch priority attribute set to high, meaning the browser will prioritize to load of these images. And for the server-side render application, Angular will automatically generate this rel preload attribute, ensuring that the images will be loaded before the page is rendered, which speed up even more the initial loading time. Right, moving into the routing strategies that ensure efficient navigation. So let me tell you another story to illustrate this concept. So think of a Netflix, for example. Imagine you just want to watch a single movie, and instead of loading just the film you selected, the apps decide to download every movie in its library. Just in case you might want to watch something else. Why not, right? And again, instead of watching the movie you selected, you are just sitting there waiting and waiting for everything to load. And that happens when Angular doesn't use the lazy loading for its routes. So with each lazy loading route, Angular automatically generates a separate JavaScript chunk, which means that user only has to download the essential code related with the specific route, nothing else. Now, to illustrate this concept, let's consider the following example. Let's imagine we have a route configuration that includes, let's say, 3 components, all set to be eagerly loaded. So without lazy loading, all components are bundled together in one big JavaScript file. Now, the browser has to process everything before rendering the first screen, which results, of course, long load times and sluggish experience. So all these 3 components will be downloaded right away, regardless of whether they will be used immediately or not. And in our scenario, all 3 components will get bundled to the main.js file, which takes right now something a little bit over 30 kilobytes. Now, with lazy loading, we only fetch the code when it's needed. So let's try to replicate the same example. But before, let's try to understand one thing. Implement lazy loading is very straightforward thing. It's built-in feature. So all we need to do is to just use the load component in our routing configuration, and that's it. So when user navigates to the specific route, only the relevant component will be loaded, which reduces the initial bundle size. Now, when we load the same 3 components from earlier example, we'll see a huge difference. So we can notice that our main.js file has decreased over 70%, which is awesome, right? We can also additionally see a lazy chunk files. The 3 lazy chunk files, each will be loaded only when user navigates to a specific route. All right, now, what if I told you that even the embedded views can be lazy? You know, Angular introduced these defer blocks which allow us to kind of load the parts of the particular page dynamically instead of rendering it at once. So again, to illustrate this concept, let me tell you a story. Again, let's try to imagine we are at the restaurant, this time with a multi-course meal. And instead of waiter dumping all the dishes you requested at the table all at once, you know, crowding your space and making it overwhelming, they serve each course only when you are ready for it. So, you know, you start with the appetizer, then you move to the main course, and finally, my favorite dessert arrives when I'm ready for it. Yeah, I'm not sure how about you, but I'm getting more and more hungry after each story, but yeah. So that's exactly how the defer blocks works in Angular, right? Instead of loading everything up front, it brings components only when they are needed. So this feature is especially very useful in application with lots of kind of non-essential content that doesn't really need to be loaded right away, but appears after some user interaction where some condition is met or when user clicks. Now I'm talking about components like, you know, expanded cards, accordions, tabs, mega menus, chats, and so on. So in this section, we'll explore the defer directive and we'll discuss the triggers, a very powerful feature that allows us to control when exactly the deferred content is loaded. So let's start. Angular has made it super easy to implement the deferrable views. Now, all we need to do is to just wrap the specific component by the defer directive and will automatically delay its rendering until the specified condition is met. So in this particular example, the app recently watched component will be only rendered when the app is idle, which means there's no immediate task pending. So this is the default behavior. If we'll not provide any argument into the defer directive, it will be treated as on idle. So those both examples are equal. Now, when we build application with that deferred block, Angular, similar to what we've seen in lazy loading routes, will automatically create this lazy loading chunk files for this deferred component. Now, Angular defers directive comes with several trigger options. So we can specify on idle, which means that we'll load the component when there is no immediate task pending. On viewport, when the component, for example, scroll to the particular component. On interaction, when user interact with some different part you know, in the application. On over, similar, but well, over mouse. On intermediate, so we'll load lazily the component immediately right after all eager content has loaded. And on timer means after some giving time. Now, we can also specify a condition to load. So, you know, we can load the component when the condition is met. In this particular example, we can load app recently watched component when the condition will return true. We can also combine a multiple triggers. So in this particular use case, the app recently watched component will be loaded on user interaction, for example, click. specifically 5 seconds after this interaction. So this gives us a fine-grained control on when the defer blocks loads, allowing us to load component just in time rather than upfront. Right, moving to hydration. So I was trying to find the right example to illustrate what hydration is, and I think I found it. And here it is. So hydration is like awaking after a deep sleep, right? But for the web page. So we are technically awake, but not quite ready to face the world yet, not quite ready for interact with different people, or at least I'm not ready. So let's take a look and let's try to understand what's happening without the hydration. So without hydration, server-side render feels like getting a fancy looking delicious cake that you can't eat yet. So you have to wait and wait before you can actually take a bite and enjoy it fully. And you can admit that it's not the best experience, right? So in a typical server-side rendering process, the server generates and sends the HTML to the client. And this HTML, however, is completely static. So when the page first appears, user can see everything, but they can't really interact with it yet. So this interactivity comes a little bit later once JavaScript is downloaded and executed. Now, this can lead to some issues like content flickering and definitely slowing the initial loading time. Also, the user experience could be a little bit better because there's this delay between when content appears and when it's actually become interactive. So the longer the JavaScript takes to load, the longer the user waits to start interacting with the app. Now, let's talk about how things change with hydration. So with hydration, the same gorgeous, delicious cake becomes instantly ready to enjoy the moment it appears. So no waiting requires, just cut and enjoy. And instead of staring on the static page while JavaScript setting up all these event listeners and all this configuration, hydration makes your app interactive right away, delivering this delicious user experience. And this means that as soon as the user receives the HTML, they can immediately see the content. So far, so good. But we're not stopping there. So once the JavaScript loads, Angular kicks in, bootstrapping the app and making it fully interactive. So the magic here is that users don't have to wait for the page to become interactive after seeing it. And everything happens much faster, loading quicker, and improving the initial time. Now, enabling hydration in Angular is incredibly simple. So all we need to add is to add the provide client hydration provider during the application bootstrap. And that's it. Once it's done, we can immediately start taking the advantages of all its benefits. Now, we already know what hydration is and that hydration boosts the initial loading time. But incremental hydration pushes it even further. So instead of activating the entire application upfront, Angular can selectively hydrate only parts of our page the user interacts with, and the rest sections remain static until needed. So how does this incremental hydration work? So first, nothing changed. The application sends the pre-rendered HTML to the browser, so user can see the content right away. But the difference is that JavaScript is downloaded only for these individual components user interact with, and activate when needed. So developers can set some conditions for when parts of the app should become interactive. And Angular provides a variety of triggers to control hydration behavior, similar to what we've seen in the deferrable views. So we have on idle, on viewport, which hydrates the component when it comes to the viewport, on interaction, so hydrates the component when user interacts with it, on over, when user over or focus on it, on timer, interact the component after some set delay. So for example, on timer 2 seconds, hydrate after 2 seconds. When means hydrates component when specific condition is met. For example, we can use this condition to check, if the user is logged in, then hydrate the content. And hydrate never means prevents component from being hydrated at all. It's very useful for non-interactive static content. So to enable incremental hydration, all we need to do is to add this with partial hydration argument to our provide client hydration provider. And from there, we can start using the defer directive to control when components are hydrated. Now, here we can see the incremental hydration in action. So the page is instantly rendered on the server, but we hydrate on over. So when we over the mouse, the JavaScript for each movie is loaded, and this way we can postpone the unnecessary script execution. All right. Enough slides, it's time for action. So let's walk through each technique and let's test them in a real Angular app. So hopefully at the end we'll see, how much faster app can be when we will be a little bit lazy. So let me present you the app I have prepared. All right. So I built a simple app that displays the movies within two main routes, the home route and the movies route. So the home route displays two sections, top rated movies and recently watched section, which is below this top rated movies. The movies route shows all available movies. So when we click on each movie, we can see an additional details. We can also mark movies as watched. For example, let's mark the Pulp Fiction as watched, and we can add it to the favorite. Once we do that, we can see our Pulp Fiction film has been added dynamically to the recently watched section. And that's pretty much all. Now, let's quickly look at the implementation of this application. So the entire app is built using the latest Angular, which is 19.2.6. The navigation is handled in the toolbar component with two buttons that navigates us to the home and movies routes using the router link. The home component loads the top-rated container and recently watched components. Both components are quite similar, so they fetch movies data from the store here and filter all movies based on some slightly different criteria. So the top-rated considering the rates and returning us 4 top-rated films. The recently watched considering this is watched flag and return only watched films. So both components based on the app movie component, which is presentational component, and this component expects two inputs signal. First is the movie itself. The second is the flag is priority, which is default set to false. So we are using this flag to determine if image is loading, or to determine what's the strategy for image loading. Our second route loads the movie list component. This movie list get all movies from the store, loop through each movie and display the movie details. Nothing special here. So movie details displays all the details about the film, the picture, which is whenever it's favorite, whenever has been watched, title, recent release date, gender, and once we clicked on this arrow button, we additionally attach this app movie expanded, which, you know, it's more about to display the cast and the description. So that's all. Let's now build the application and let's check in the Lighthouse what's the initial score for our application. So I'll use the HTTP server to run our dist folder on the browser, and it's running on the port 8080. So hopefully it will not be close to 100 because probably I'll not have anything to improve there, but you know, live demo is a live demo. You'll never see. Yeah, it's 60, so could be better, but it's not that bad. So let's check how we can improve our application to get higher score in a Lighthouse. So first of all, I will run it locally first. All right. So first of all, after running, we'll see that, here it is. We'll see that ngOptimizedImage directive returns us an error because it detected that some images as part of the LCP element and was not marked as dirty, which is very useful. Let's fix that first. So I believe it's about the top rated images because this part is not part of LCP. Those images which are preview of each movie should be prioritized because users should see those movies right away. So let's go to our top rated movies and let's say, hey, I would like to set this is priority to true. And that's it. Let's try to verify if the error gone. Right. So right now we can see, hopefully the font is big enough. We can see that after we setting a priority images, we have loading set to eager and fetch priority set to high, while these bottom images are by default lazy loaded, right? So those would be lazy loaded, those would be prioritized and loaded by the browser as a first. Then what else we can see? We can see, for example, that our main bundle has 54 kilobytes and there is no any lazy loaded chunk, which means all the routing is set to be eager. So let's change that. And let's say we would like to use the load component, which import the movie list and movie list component. Then we'll load the movie list component. All right. Now, if we'll take a look a little bit closer we'll see that when we navigate to the movies route, this additional chunk will be loaded. And right now, our main bundle has been decreased to 29.1 kilobytes, which is awesome. So not much work, but a great effect. What else can we do? Well, because this extended part, this additional information is not like a very essential content that has to be rendered immediately right away after page is loaded. We can defer this content and load it separately. So let's try to do this. So we can see that this content is loaded here. So now we can say, hey, please load this content on interaction with this expand element, right? And now when we'll build our application, I would like to demonstrate what's the result of it. And we'll run it into the browser on port 8080. Awesome. When we'll move into the movies route, we'll see that after expanding, an additional chunk is loaded, which is great. Maybe it's not a big chunk, but this is just the example. Imagine that you have like a mega menu with lots of different links. It would be definitely a bigger chunk. So last thing that we can improve is our main homepage. So as we can see, after starting a homepage, we can see only the top rated movies, but we can't see recently watched section, right? So what we can do is to utilize the incremental hydration and lazy load this bottom section once the user scroll to it. Means this section will be entered into the viewport. So let's try to do this. All right, we have our home component. We are loading both components eagerly. Now I would like to defer hydrate on interaction. Yeah. All right, and because we are using the hydration, it would be very nice to have SSR application, right? So let me find, yes, here. Let's add the Angular SSR library. Hopefully it will not take forever. All right. Right, so now we can see we have provide client hydration. By default is with event replay. We would like to have this one with incremental hydration. All right, so now all is set up, and let's run our application. So to run our application, when we add the package SSR, Angular has generated a separate script for us, which runs on port, I believe, 4000. Or not. Oh, yeah. I believe we need to build the application first. So let me remove this folder. Let's build the application once again, and let's run it with the server-side rendering. All right. Now, yes, it's working. Now, we can see that, let me refresh. We can see that many chunks are loaded. However, my mistake, not on interaction. When this section comes to the viewport, I'm sorry, this is the part of the live demo. So let's rebuild the application and let run it once again. All right. Now, hopefully that's the last time. Yes. So once we scroll, we can see this additional chunk is loaded, right? And this additional chunk is responsible for this section, basically. So we can split this entire page on multiple different pieces. I call it slice the elephant, basically, and load each part when it's actually needed. So now, after these few improvements, let's verify how the Lighthouse score improved. Hopefully, it's close to 100. I doubt it would be 100, but we should observe some improvements. Yes. So as you can see, by doing only a few operations, which takes a few minutes, we almost double our score, which is awesome, right? All right, let's go back to our presentation, and I believe that's it. So I hope we prove that, slowing things down in the right way, we actually speed things up. And by lazy loading images, routes, components, optimizing hydration, leveraging incremental hydration, we make our apps faster, lighter, and more efficient. So go for be lazy, build incredible, fast apps. Thank you so much.
Okay, thank you, Arek. That was a nice presentation with a lot of interesting analogies and a live demo, which is always tricky. So really appreciate it. So now let's jump into the Q&A session. So let me look. Okay, I believe we have one question which was kind of answered already in the chat, but it would be good to highlight the difference and sum it up. So from Saida Ansari, is defer condition same as ngIf to load components lazily?
Not really. So the third block is splitting our bundle into two separate chunks, while ngIf is structural directive which hides the part of our template and display it once the condition is met. So it's still the same part of the same chunk, basically. The ngIf does not split the bundle into two separate parts. Hopefully I did answer this question.
Yep, I think so. And then we have another one from Gulam Asgar. How can libraries like Canvas.js be loaded and rendered immediately in Angular when they only initialize after user interaction due to hydration or hidden state? For example, tabs models. Yeah,
Okay.
take your time. It's kind of a long and complex question.
Well, I'm not the expert. I haven't used actually the Canvas.js library, but I think it's like more general question where how to initialize this library after user interaction due to hydration or hidden state, right? So I think there's some probably I would use some general dynamic imports or something like that. I'm not sure, each library has different API, and each library could be initialized in a slightly different ways, basically. There's some libraries or some packages that shouldn't be initialized multiple times. So we need to be aware that once we are using the defer blocks or hydration, we are not initializing the same thing multiple times. I'm talking specifically about the newest HTTP resource, for example, which should be initialized only once and then just called in the application. I'm not sure how the Canvas.js, to be honest, is initialized, but if it's through the import, I would go for like dynamic imports or so.
Yeah, I guess that's probably where we should start. So I hope that this answers the question. And there is one more. I'm not really sure, but let's try it. From Surbi Apatyai, do we need separate API for defer components?
What does it mean? Do we need separate API for deferred components? So deferred components are the same components, but just lazy loaded, right? So the API for each component in Angular is exactly the same. It's more about how the component is loaded and how the component is treated by the browser, rather than we need to implement anything specific inside this component, right? So defer directive allows us to slice this particular component or take this component from the main bundle, create from it a separate lazy loading chunk, and load this chunk into the browser once it's needed, when the condition is met or when there's any interaction. So there's no any specific API for lazy loaded components.
Okay, right. Hopefully we answered the question. And I believe we've reached the end of our Q&A session. So again, thank you, Jarek, for being with us today, for the great presentation. And yeah, I hope to see you soon.
Yeah, thank you for having me and thank you for the invitation. And definitely see you soon